Hello, bonjour. Today we are going to look at pressure. I am going to talk you through basically the entire topic of pressure very, very quickly. There is some fill in the gap sheets. If you'd like to do that, you obviously do not have to. In fact, if I'm honest, you don't even have to watch this video. If you think, I know P1, I know pressure, then don't worry, that's not an issue. I'm doing this video because it was requested by one of your year mates. So yes, they asked if we could do a bit more on P1 pressure. So here we go. So I'm going to talk through very quickly. Obviously, feel free to pause at any point. So the basic thing is pressure is force per unit area. The bigger the area force pushes down on, the more the force is spread out, and the smaller the pressure. It is measured in newtons per metre squared or pascals, hence the picture of Pascal from Tangled at the top there, looking wonderful in pink. So gases exert a pressure because in a gas, as you know, all the particles move round, here, there and everywhere. And whilst they are moving around, they will collide, both with each other, but also with the walls of the container. And it's these collisions with the walls that cause that pressure. Every time a gas particle collides, it exerts a force on that wall. When you blow up a balloon, you're increasing the number of particles in the balloon. So you're increasing the number of collisions. This increases, so clearly a typo there, this increase in force from the collisions make the balloon expand. And a lovely photo from Up on the right. All the Pixar movies today. So the next thing we're looking at is the link between pressure and temperature. If you increase the temperature, you are going to increase the energy, kinetic energy specifically, of the particles in your gas. So your particles will move faster. So they will collide more, but also every time they collide, they are going to be colliding with a larger kinetic energy and a larger force. So you have more collisions, and now each one has a large force, so there will be an increased pressure. So the higher the temperature, the higher the pressure. Now the next thing is quite a famous graph, which is a pressure and temperature graph for a gas. Now if you have a look at the right hand side of the graph, you will see that at 0 degrees C, there is a certain amount of pressure. And so scientists increased the temperature of the graph, and they saw the pressure also increased. Fabulous. But they thought, okay, what happens if we keep going backwards? If we make it colder and colder and colder and we keep monitoring the pressure? So they did, cold and cold and cold and cold, and they kept monitoring the pressure, and eventually they realised that at minus 273 degrees, there was zero pressure. And that is what we call absolute zero, that temperature. And it's also our conversion between temperature in degrees C and temperature in Kelvin, which is, if you remember, starts at absolute zero. So 0 Kelvin is minus 273 degrees C. 0 degrees C is 273 degrees Kelvin. So there you go, pressure and temperature, done. Next thing, volume and pressure. As you decrease the volume, so for example, if you squeeze a balloon, the pressure will increase. And likewise, if you increase the volume, the pressure decreases. We say they are inversely proportional, which is a phrase I'm hoping you know from maths. So if one doubles, the other halves. So here you go, you've got two plungers, syringe type things. On the left, you've got a large volume and a low pressure. And that's because basically those particles can have more space to move around, so they're going to collide less. B, where you are decreasing the volume, there's obviously less space for those particles to move, so they're going to collide more and the pressure will increase. Now there is an equation here. P1 times V1 equals P2 times V2. You may also see this written as pressure times volume equals constant. Now it means exactly the same thing. I always teach it with P1, V1, P2, V2, because I think when you're in year 9 you find it easier to understand, but you might say it's pressure times volume equals a constant. And here's an example question. If the pressure of a gas is 3 pascals when the volume is 2 meters cubed, what is the pressure when the volume is 6 meters cubed? So you write down what you know, you pop it into the equation, and it should come out as 1 pascal. But please feel free to pause the video at this point if you want to see any more. I'll take it a little bit slower. Right, the next equation we're going to look at is our classic pressure equation. Pressure is force divided by area. You do need to learn this one. Just a reminder, pressure, pascals, force, newtons, areas, meters squared. Okay, next thing is height and atmospheric pressure. So at the atmosphere, in fact this should be the other way around really. The atmosphere is the sea of air and gas that surrounds our planet. It's attracted to the Earth because of the Earth's gravitational field. And we are obviously at the bottom of this cloud. And so all of that gas and all of that air pushes down on us. And sideways and upwards and, all around us. But either way, there is pressure from the atmosphere. And that pressure is a number that you are expected to know, 100,000 pascals or 100,000 newtons per metre squared. Now, if you go up a mountain, for example, or in an aeroplane, there is less air pushing down on you and around you, so there's less atmospheric pressure. So the higher you go, the less atmospheric pressure. And likewise, the further down you go, the more pressure. Now we can link that in to pressure in a liquid. Pressure in a liquid acts in all directions, so it should also be acting down and acting up. It is greatest at the bottom of the liquid. Just same idea as the atmosphere there. There is an equation, which is, in fact, let's change that. Pressure is density times gravity times height. Now, for my year 9s, again, occasionally I'll put density as a D, but really it's a Greek letter rho. In fact, that might be a better rho. Apologies, 3 times lucky there. So, pressure is density times gravity times height. If you want to remember a triangle, you have pressure on top, rho, G, H on the bottom. Just a reminder that gravity will not be given to you in the question, that is always 10 on Earth. And that's it, I think. That's probably quite a lot. You've got all your equations there, so just pause on that, and I'm hoping that's enough for you to remember how to do everything. All right, thanks everyone. There are some worksheets, etc. on Google Classroom. Bye.